Welcome to Math 105, Chapter 7.4, where we talk about probability and counting techniques. So in our previous section, we learned how to calculate the probability of equally likely outcomes. Now, what we're going to do is we're going to go kind of back in time where we talked about these marble problems in Chapter 6.4, and now pair it with what we learned from Chapter 7.3, probability. So looking back at our chapter 6.4 notes, right? The first thing we do is we totaled up the number of marbles, and then we said, hey, how many sets of 4 of this 11 or sets of 3 of this 11 do we have? Now, what we're actually doing here, that is your sample space. This, in fact, I wonder if this will show up. This is going to be the total number of possibilities, a total number of outcomes. So based on if we're pulling 3 or 4, the bottom number here will end up changing. So in this case, if we're looking at this event, the probability that we're selecting for such that that each one is a different color, well, this 18 is now the event, the number of times this event has occurred. And to kind of like review what we've done, after we did 11 choose 4, and we had 330 different ways, of which 18 can be of one of each different color. So we said here in our bag, we have 1 red, 1 yellow, 1 blue, 1 green that we want to choose. So of the 3 total red, we're going to select one of them. Times, it's a requirement that we get more colors, more marbles. So then of the 2 yellow, we're going to get one of them. Of the 3 blue, we're going to get one more. And of the 3 green, we're going to get one more. Now we can mess around with this as much as you want. We could do the experiment again, just maybe by selecting a different red one, right? So we can have 18 different ways to pull this experiment. So the probability of this experiment is 18 over 330. Now, for those of us using a not a graphing calculator, TI-83 or 4, when you do 18 divided by 330 and hit enter, let's say WebAssign does not want the decimal, but it's also counting yours as incorrect, or maybe it says a reduced fraction. So now what you're going to do is hit the math button, and that first option that says for fraction is going to replace your decimal answer into a fraction. Now the fraction that we put in and the fraction that we get out are equal. It's just this one in pink that you're seeing right here is the smaller of the 2 fractions. It's just been reduced. So if we were to do it again for this next one, right, we had 9, which is, again, the number of events. So we would have 9 over, this time because we only pulled 3, 165. Now we could keep doing this, right? Instead, we said, okay, how many sets of 3 in which all the red ones are selected? Okay, well, if this is the number of ways your event has happened, then we're doing 1 out of 165. To do this one, we said, okay, well, all the red, well, of the 3 red, we want to pull all 3. And because we need 3 in hand, this number always representing what we have in our hand, we don't need any more, so we could be done. However, if we change it up to sets of 4 and now all yellow, well, of the 2 yellow, we want all 2, right? So I have 2 yellow in my hand, but do we need any more yellow? Well, I need 2 more to make 4 in my hand. So we went back into our bag. And this time, because we're not allowed any more yellow, these ones actually happen to be on our hand, we have 9 left. So of this 9, we just need 2 more of any color. So that would be 36. So we have 36 out of 330. Again, reducing your fraction. Then we said we can have a few more variations of 4, none of which are green. So no green, we said, hey, I'm going to take all of this green and I'm going to discard it away from the pile. So we're left with 8 marbles. Now, of the 8 marbles, I can select any 4. They're not telling me I need a certain color. So any 4, I reach into my bag and just grab 4 at random. So if we have 70 over my 330, got 7 over 33. We did it again. We said at least 2 are red. Again, sets of 4. So when it says at least or at most, then we're going to have some things called alternatives. Either this happens or this happens. So at least 2 means 2 or more. So I can either do an experiment where I have 2 red at most in this case, or I have an experiment where I have at most 3, right? And not at most, I have 3 or I have 2. So in this first scenario, we said 2 red. Okay, so I'm going to take 2 of my 3 red, and then I'm going to say, well, I'm not allowed any more red, right? The 3 is reserved for the next one. So all 3 red are taken up, whether I have 1 discarded and 2 in my hand. That is great. I don't have any more red in my bag. Instead, I have 8 left. So of my 8, I still need 4, of which I have 2 red. I just need 2 of any color. So of the 8, I pull 2 more. I multiply because it's a requirement to get more, so I got 84. Now, if that's one way to do it, then I'm going to look at the other way. So we have 3 red of my 3 red, right? We are going to pull, we're going to choose all 3. So I have, again, no more red in my bag. I have 8 remaining, of which I just need 1 more. 1, 2, 3, I just need 1 more. So we said in total, I have 92 out of 330. Again, that can be reduced. We did this a number of times, okay? But the big takeaway is that however many your event is, we're going to divide over your total. So now it's your turn. So pause the video, see what you picked up from chapter 6.4, which wasn't all that long ago for those that were doing the online. So in your bag, we have 2 red, 4 green, 3 pink, 3 blue, and 2 yellow marbles. Find the probability of grabbing 5 marbles at random. Okay, so let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 red marbles. Or sorry, not red. We have 14 total marbles. Now of the 14, we're going to choose 5 at random. 2002. Now this is going to operate as your sample space. This is your sample space. That's the number that you're going to be dividing by each time, as long as we're talking about grabbing 5 marbles. I don't know why it said find the probability. We're not finding the probability. We're just finding your sample space. And it could be 5 at random. Okay. So now let's find the probability of selecting 2 green and 1 of each color. So you said, okay, I want 2 green Red, how many red do we want? 1 red, 1 blue, 1 yellow, uh-oh, I don't even have pink. Oh, I must have said, oh, I even see it on my notes here. I'm gonna say excluding, gotta now update these notes again. Exclude yellow. So excluding yellow, I don't want any more yellow. No yellow. And that will act as pink, 1 pink. Okay. So it's very specific. It wants 2 green. So of my green, how many do I have in total? Well, I have 4 total green, of which I'm going to be selecting 2. So 4, choose 2. Okay, so I got my 2 green. They are in my hand. This comes out to be 6. Okay, now is it a requirement that I go back and get a red or a blue or a yellow and so forth? Yes, I have to go back and get some more, so we're going to be multiplying here. Now, of my total red, how many do I need to choose from? Right? Of my 2 total red, I'm going to choose 1 of them. So 2 choose 1, which is 2. Okay, can move that over a little bit. Now, of my 3 blue, how many am I going to select? I'm going to select 1 of them. So 3 choose 1, which is 3. Am I allowed any yellow? No. Now what you can do is either ignore the yellow or you can put in the yellow. So of my 2 yellow, we're going to choose none of them. We don't want any yellow. That still comes out to be 1. And then of my 3 pink, I'm going to select all 3. I mean, no, not all 3. I'm going to select 1. Sorry, I thought I saw the 3 and I say that number. Okay. So we have 6 times 2 times 3 times 1 times 3 for 108. Again, just by putting in your colors in here and blue. There you go. So you have 108, which is acting as your event. So the probability of your event here is 108 over 2002. All right, let's try it again. Find the probability of selecting all the yellow marbles. Again, we're still going to be selecting 5 in your hand for all of these problems. Okay, so selecting all yellow. So let's work on your color first. So how many yellow do you need? Well, we need all of them. So of the 2 yellow that we see, we're going to be selecting all 2. So those 2 go in my hand. We no longer need them. They are in hand. Now there's only one way to choose from there. Now, if I need 5 in my hand, 1, 2, 3, 4, oops, sorry, 1, 2, 3, 4, 5, wrote too many, right? If I have these 2 yellow, how many more do I need in my hand? Well, I need 3 more in my hand, right? These 3 more to make 5. Now, how many are left in the bag at this point after selecting the yellow? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 in my bag that I need to pull from. Doesn't matter which color. They just said, make sure you grab all of the yellow ones. So we have 220. It's a requirement that we get those 3. So we're going to multiply get 220. Now this is our event. So the probability of this happening is 220 over 2002. All right, let's keep trying it. Let's find the probability of selecting at most 2 pink marbles. At most 2. What does at most 2 mean? At most 2 means 2, 1, or 0. 2, 1, or 0. Just no more than 2. Sorry if you can hear some noise in my background. Okay, now there are 2 ways of doing this. Okay, let's see. Oh, I erased one of my hands. Gonna have to draw a hand. Okay, so I'll show you one way to do it and then we'll show you another way. So our first scenario just means we could start with 0. I want to start with 0 because most students forget 0. So 0 pink. So, right, at most 2 means no more than 2. So if you're not allowed any pink, we can discard all 3 pinks. 1, 2, 3, and put them here. I have my 3 pinks. There were 14 in the bag. 11 minus the 3 pink means that we have, 14, meaning we have 11 total in the bag. So no pinks. I have 11 remaining. I can select any 5 at this point. 11, choose 5. 462. So that is one scenario of no pinks. Let's try it again with 1 pink. 1 pink. So I want 1 pink here. So this pink in hand. So of my 3 pink, I'm going to choose 1 of them. Now it's a requirement to go back and get some more. So if I have that pink one in my hand, then the remaining are discarded. We're not allowed any more pink in the 1 pink scenario. So then again, how many are left in your bag? Well, I have 11 still remaining, of which I need 5 in my hand. So we need to go back and grab 1, 2, 3, 4 more. 11, choose 4, 330. Now it is a requirement that I go back and get more. So we're going to multiply here, get 990. So that is 1 pink. Let's try it again with 2 pink. Go over here and do 2 pink. Space them out so far apart. 2 pink. So of my 3 pink, I'm going to get 2 of them, of which there's 3 different ways. So these 2 pink go in hand, and this one gets discarded. We're not allowed those 3 pinks, right? So discard, we still have 11 to choose from. I have 2 in hand. I just need 2 more, or sorry, I just need 3 more to make 5. 11, choose 5. Oh, not choose 5. 11, choose 3 to make 5 is 165. Again, it's a requirement to go back and get some more. So you have 495. Now, because these are alternatives, right? We could either have a 0 pink scenario, or we can have a 1 pink scenario, or we can have a 2 pink scenario. We're going to add all of these values up. So we can have 1947 over 2002. Okay, so now that takes a lot of work. So instead, can we do something else that we kind of touched upon in chapter 7.2 and again in 7.3, right? If we can negate that fact, if we can find the event that we don't want, and then can we subtract it out from your total, right? So at most 2 pinks means just no more than 2. So what if we selected, can we pick all 3 pink? So of the 3 pink, we're going to choose all 3. Now, because we need more marbles of the now 11 remaining in the bag, we just need 2 more, 55. And because we're required to go back and get more marbles, right, we have to multiply. Now, this is the event that we don't want to happen. This is the event, right? 3 pink. But we don't want 3 pink. So we don't want 3 pink. So if we take the probability of the probability of not selecting the 3 pink, we're gonna go find your total number of events, 2002, and subtract out the event that we have, the 55. To get 1947, have we seen that number before? Sorry, that's not the probability, that's just the number. Well, yeah. From there, we can then go ahead and divide. So if you find that it's a lot of work to do all of these alternatives, instead, you can just find the alternative that you don't want and then subtract that out from the total. All right. Find the probability of selecting no red marbles. So of those 2 red that you're seeing, they are going to be discarded. So of my 14, I'm going to subtract out my 2, of which there are 12 remaining. I can then just put in any 5 marbles into my hand. So of my 12 marbles, we're going to choose 5, which comes out to 792. 792 divided by 2002. That would be selecting no red marbles. So make sure your foundations in that marble problem is solid, because you're going to be seeing it throughout the semester. And definitely go back and rewatch the 6.41 for a little bit more in-depth process of it. All we're doing is just now tacking on probability. So our last example, example 2, says a test has 3 parts. Now what I'm going to encourage you is to pause the video and see if you can at least get this started as far as like part A, B, and C, and then come back if you have questions on it. So a test has 3 parts. Part A consists of 8 true-false questions. Okay, so I'm going to write that part down. We have part A, which has 8 true-false questions. Part B consists of 5 multiple choice questions. Five multiple choice questions with 5 different choices, 5 options. This one has 2 options. Part C requires you to match 5 questions with 5 answers, one-on-one. Part C, we have 5 matching questions, each one-on-one. So assuming you make a random guess filling out your answer sheet, what is the probability you will earn a 100% on the test? Okay, so let's look at part A first, right? True, false. True, false, and so forth, true, false. Okay, your first one has 2 options. Your second one we said has 2 options, and so forth, 2 options. What did we find was the easy way to write this out? Because our question wants our answer in a formula, so we can't just like put it into your calculator. So we have 2 options. That's not going to change, but what will change is the number of questions. So we have 2 to the 8. Always the number of options on the bottom, or sorry, option on the bottom, questions on top. Okay, so multiple choice. We have 5 multiple choice questions, each with 5 different options, A, B, C, D, E, A, B, C, D, E, A, B, C, D, E. We have 5 options, again, 5 options, and again, 5 options. So instead of multiplying 5 times 5 times 5 times 5, find an easy way to put that into a formula. So of your 5 options, we have 5 different questions. Always the options here and the questions above. I'm going to move this up just slightly. Okay. There's good. All right, one more time now with matching. So we have 5 matching questions one-to-one. So for an example, let's just say A, B, C, D, and E, 1, 2, 3, 4, and 5. So let's say A goes to 1. So A to start with though, how many options did A have to start? Because we haven't done anything, right? Well, A here now has 5 options. It could have gone to 1, to 2, to 3, to 4, to 5, right? 5 different options. What about B? How many options does B have? Let's say I went down to here, right? It has 4 different options, right? C has how many different options? 3 options. D has 2 options. E has 1 option. Have we seen that before? Yeah, this is just a factorial. This is a 5 factorial. It's just saying 5 times 4 times 3 times 2 times 1, right? So 5 factorial. Now, what we need is your answer to be in a formula. So since they don't tell us that part A, B, and C are optional, right? What is going to happen between this part, and this part? Well, they're all going to be multiplied. So we're going to at least have that bit. And I'll put it, let me separate these out just a little bit more. Part C over here. Part B over here. Move that over just a little bit right there. Okay. So we have all of these. We have 2 to the 8th times 5 to the 5th times 5 factorial. Now this, if we multiplied all of these out, these are the total number of ways to answer your test, right? All of the number of ways to answer your test. But if our question is to get 100 on our test, well, how many different ways can you get 100? There's only one way to get a 100%. So if this one is signifying the one way, then your event, right, to get a 100%, there's only one way, and below it are all of the different ways, different combinations you can answer this test. The probability is just to divide the one way to get it over the total ways to answer. So this is what your answer would look like. 1 over this whole amount. And there you go.